Hey everyone, welcome back. In this video, I'm going to be focusing on the data layer, feasibility, and the transformation layer. In my project that I'm building in Microsoft Fabric, I'm essentially trying to take an AI-first approach to development to try and understand what impact it will have on how we build Fabric platforms in the future. So this is going to be video 4. If you've already missed video 1, 2, or 3, then I recommend you go and check them out. I'll leave a link somewhere up here so you can go and do that. It'll help to understand where we are with this series so far. But the focus today is more on this section of the architecture here, transforming raw tables down this side into gold transformed, validated, everything like that tables ready for our ontology so that we can bind them successfully to our ontology. Obviously, lots of different technology options you can use for this. The core requirements, because of the focus for this series and this platform that I'm building, well, obviously it needs to create transformations. That's the core purpose of that layer in the architecture. It should also enable what I call a closed loop development approach, whereby you can develop, you can execute your code, you can test your code, you can test the data as well based on the transformations, all locally. And it makes it easier to integrate because we're doing everything in VS Code. Integrate the state-of-the-art AI models. A lot of the action in the AI space is happening in tools that integrate nicely into VS Code, like GitHub Copilot and Claude Code, which is what I'm using for this project. Even better if it's free and open source. So based on these core requirements, the candidate that I want to test for feasibility in this project is using DuckDB in combination with DBT. So these are two separate open source projects, or at least DBT core is open source. They can be used in combination to hopefully help us achieve these requirements here. And we're going to see what that looks like in this video. Specifically, I was interested in, how we can combine DuckDB, DBT, and Fabric, but I want to adopt, obviously, best practices in terms of deployment, testing, data quality. All of these elements I want to be included in this architecture. So for my own benefit, I just want to check that, I can manage assets that are being created with these tools in a way that aligns with my own goals in terms of using an AI-first approach, and can it be deployed across dev, test, and prod quite easily. Before we get into the workflow that I've landed on in this project, I do want to spend just a little bit of time. If you're completely new to these technologies, it's a bit of a foundation. Otherwise, you probably won't understand any of the rest of the video. So DBT essentially is just a transformation tool. It helps us write SQL or whatever your engine that you're using DBT with. It basically compiles code that you can run in your system, in your warehouse, in your lakehouse, whatever you're using as your data store, in a wide variety of technologies, Snowflake, whatever, pretty much every data warehouse solution provider you can integrate with DBT these days. And so you can go from raw tables, staging tables, to some sort of transformed table. Now, obviously, we have a few different tools to do this in Fabric. You could use a notebook. You can use T-SQL, like store procedures, data flows. Even now, you have materialized lake views. That's an interesting one because these also have a similar property to DBT in that they are declarative. So instead of describing the transformations that you want to make, you instead describe the end goal, the structure of the final table here, and like everything else gets sorted out or designed and built for you, really. This is what I'm saying with this second slide. So this is the next thing to understand about DBT. We just write select statements. They call them models here. We define what we want our data to look like in the target table or view. And then DBT figures out, okay, I need to build a transformation that gets the data from X to Y under the hood. So our role is just to build these models. We can also, with DBT, quite easily implement some basic data quality checks and schema checks so that every time your pipeline runs, we can tell it to also check that the data is still in good shape. Things like unique null values, checking the column names and column numbers and that sort of thing. Fairly basic, but you can also add your own custom SQL tests in here so you can get as advanced as you want, really. This is one of the key things that I really like about DBT. And specifically, I think is really important as we move to a more AI-driven approach to transformation writing. If I'm using AI to write my transformations, then I want to have a very, very heavy coverage of testing and data quality testing and make sure that there's no regression. So if you introduce a new transformation, I want to be sure that the other 20 transformations that you've already got, even the ones downstream, are not going to break. This is a really nice way of giving us a little bit of comfort in that transformation layer, that even if we're going to lean more into AI development in terms of writing our SQL models or whatever code that we've got in that layer, I want those tests to be running every time the pipeline runs to make sure that we've still got confidence that our pipelines are working and the data is of good quality always. So these two in combination, well, from the SQL data models, DBT compiles SQL code that runs against our source. Now, because of the syntax, there's what's called like Ginger templating syntax, which means it's got a few like special bits of syntax, like this reference to reference other tables. Because of these sorts of features, DBT also has inbuilt lineage tracking. Now you can do this at the table level on the free plan, or if you sign up to DBT Cloud, you can get column level lineage tracking, which is pretty good. Now for this, I'm just using the free DBT core. You can see a pretty good example if I go into, just to give you a bit of a sneak peek about what we're going to look at later in the video. If I go to one of my models here, I'm in VS Code, and I'm actually using a free extension called Datamates that allows you to view the lineage. It's not quite as nice as you see in DBT, but I can see that, okay, I've got this film table, and it's dependent on data from these other tables, okay? So you get some pretty nice lineage just because of the way that it's defined. So just because we're using these references in here, so this one's joining from quite a few other tables to create this film table. And that also dictates the order in which they refresh the models. So it's very, very handy because lineage and dependency tracking is all done for you from the use of these references. Similarly, when we define our tests in YAML, there's a few different ways to define tests in DBT, but YAML, one of the easiest ways, and that then again compiles into SQL code these checks that gets run in your warehouse or in your lakehouse if you're using like the Spark connector. But that does bring us on to some options for integrating DBT, because there's quite a few, and this list is actually expanding now. You might have seen the new DBT job in Fabric. It's very new and it's a little bit limited, I would say, at the moment. But what they're trying to do is give people the ability to author and manage their DBT models and jobs within Fabric itself. So kind of like as a managed service inside Fabric. So currently it only integrates with the warehouse. So if you're looking to use a warehouse, then by all means have a look at that one. I'm not going to be using it for this project because I want to be using lakehouses at the moment. The other options that we have are DBT Fabric, DBT Spark, and the one that I'm going to be showing you in more detail today that I've been exploring the feasibility of is the DBT DuckDB adapter. So the way that I would probably describe the differences between all of these different things are in the engine that the code or the scripts run on and the target environments. So with DBT Fabric, it's a Microsoft managed or community managed adapter built for the data warehouse. Okay. So it's going to use the warehouse as your target. We also have, as part of DBT Labs or the DBT adapters owned by like the company that owns DBT, they manage this Spark adapter. So it's not like a Microsoft Fabric Spark adapter, but you can use it with the Spark engine. And obviously you can write the lakehouse tables as a target. The third option here, and the one that I've been exploring in more detail recently, is the DBT and DuckDB adapter. So this uses DuckDB and we run it with Python as the engine. So technically it's not really using like the inbuilt Fabric engines like the warehouse or the Spark engine, but with a little bit of tricks using some kind of like plugins like DuckLake and Delta Export, then we can actually get it to write to lakehouse tables or write Delta format tables that we can put in our lakehouse. So the DBT and DuckDB adapter is where I focused a lot of my own research just to try and understand what this is, how it works, how it might be useful for my project. There's a few key features that we can talk about. I'll probably show you the code and show you the project setup because I think it will help you understand. But essentially, it runs on raw Python, right? So we can run them in Python notebooks, all of our transformation layer. Plus, we can also do that locally in VS Code. So that's one of the key features of this approach. And I'll show you the mechanisms that enable that. Because of that, we can enable this closed loop development cycle with this approach, where we can write, execute, test, refine, and deploy to Fabric when we're ready. I will say that my own research looked a bit like this. So the feasibility study was fortunately and luckily guided a lot by the work by Mim Jwala. So if you're not following Mim's work, I recommend you definitely take a look at his. He has a website called Data Monkey Site. I can leave it as a link below. And I've been following him for quite a few years, really, actually. And he focuses a lot on DuckDB and understanding the underlying Delta format and iceberg formats and how all of this integrates into OneLake kind of behind the scenes. He's also focused a lot on small data and working with OneLake locally as well. And so Mim's project was really the big inspiration for this approach. And I used a lot of his resources as the starting point for my own research. Okay. He has a repository called DBT Fabric Python Notebook. He also created this library called Delta Export, which I'll be showing you in a moment, that helps us translate the Parquet files that DuckLake traditionally works with, and it converts them into Delta tables that we can write to OneLake. So again, I'm heavily leaning on the work by Mim Jwala here. So definitely recommend you check out his stuff. The process I took was, essentially I studied Mim's repository, because if you're new to all of these concepts, it can take a little bit of understanding how everything's wired together. So I spent quite a lot of time understanding specifically like the DBT, how that integrates with DuckDB. And then we've got things like DuckLake, which transform it into this metadata.db, plus how the Delta export works. And I'll walk you through my best attempt to try and understand and communicate how all these things work in a second. I then worked with Claude to try and re-implement Mim's workflow step by step. So I worked with Claude to say, okay, I've got this repository from this guy called Mim, and I want to work together to re-implement it in my own environment step by step, because there's a lot of features and parts to the Mim example that are difficult to understand if you just look at the final result, right? Whereas if you ask Claude to help you build the project from scratch, then you can understand how it all fits together and what role each part of the configuration files play. So after I've done that one, I also designed and implemented my own proof of concept based on the learnings that I took from the first two sections here. And with a good understanding of how it all fits together, I've made a few changes based on my requirements for this project. Specifically, there were a lot of changes made around the deployment process, okay? Because this is one of the areas that I wanted to focus on a lot in my feasibility studies in this area. I wanted to be sure that because the deployment of these sorts of systems is very different to the traditional deployment mechanisms that we might be familiar with in terms of deploying notebook code or deploying even things like database projects in the data warehouse. Because as you'll see, we're essentially just deploying metadata and configuration files. I also had a slightly different development CI/CD prod workflow, which is, I guess, related to deployment as well. Because I'm targeting this ontology-driven architecture, that does impact the deployment workflow a little bit. The other deviation from Mim's example repository is that I'm working with slightly different sources. So in this repository here, Mim works all the way, actually, from REST APIs, getting some CSVs from those REST APIs, and then showing you the full end-to-end process of transforming them and even building Power BI at the end. In my example, I'm not calling REST APIs with DBT. I don't want to do that with DBT. I just want to go from my raw layer, which are delta tables. They're going to be delta tables here. Okay, I just want to use DBT for this section here. So it's a slightly different problem in that we already have pre-existing tables here that we need to really connect to, or at least be aware of what they are, because we need to use those as the basis of our DBT transformations. So that was a slight deviation again, based on the differences with MIM. So I think now I'm going to transfer you over to the VS Code environment, and I'll walk you through, bring some of those concepts alive to what that actually looks like in the code here. And we'll go through some examples as well. I'm working here in the same Fabric BMAD project that I started. I've got a bit of a feasibility area developing now. So in the last video, I looked specifically at the ontology stuff. So all of that is in there. So I just created a new subfolder really to store all of my stuff. And you can start to see the structure here actually that's quite important. The MIM example is essentially taking MIM's work, and I have asked MIM if I can talk about his work on the YouTube. So thanks very much for agreeing to that, MIM. And thank you very much for sharing your knowledge and doing these investigations yourself, because a lot of the solution is built on your foundations. So thank you for that. Then I created my own one from scratch based on the same principles, but I worked with Claude to say, okay, I want to develop a solution similar to this one, but I want to build it up step by step, right, from an empty project. That really helped me solidify how all the pieces fit together in that solution. From that, I then created this POC local dev where I introduced my own elements into the solution based on my own requirements. And then I did this POC final, local final clean, which it looks like one of those docx files that's like final, no final, final. But that is essentially what it was. It was just a cleaner version of this POC, because that one's a bit messy. All of this feasibility area is research, right? So it's not production code. I'm just trying to prove that I can get these tools to work in a way that I want them to work in. So let me first outline the MIM example and some of the key features, because we can start to understand how DuckDB works and how DBT works and how we can get that to integrate into OneLake and Delta as well. So if we start to open up the MIM example DBT project, there's elements, if you've used DBT before, that are going to be the same. So we've got like a profiles.yml, a DBT project YAML. We've got our models, macros. The targets gets generated when you run DBT run, and some tests. Okay, so all of that looks pretty similar. The interesting part to dive into, maybe to begin with, is this data folder. Now this gets generated as part of the DuckDB and the DuckLake specifically part of the extension, I believe. Now this is what's somewhat unique in the DuckDB approach, in that we're actually building tables locally. And these aren't just any old tables. If you're using raw DuckLake, then these are going to be Parquet files. But because of some of the configuration tools that MIM has built, we can actually get it to convert the Parquet files into Delta tables, which is obviously very handy for us working in Fabric, right? So every time the DBT runs locally on our machines, it populates this data folder. In MIM's example, he also uses it to get data from a REST API. We're not going to be doing that in our final solution, but that's why there's a files area as well. And the output is both landing tables, but also mart tables. And these are Delta tables. Okay, so we can click on them. We can see the Delta log, like the JSON log here. So these are proper Delta tables. Now, this is all made possible because of, like I say, that extension. If we go to the DBT project, you'll see MIM's included in his configuration this on-run-end hook. This calls 3 DuckLake functions and 1 custom extension that MIM has built himself called Delta Export, that essentially take the Parquet file, that is the default for DuckLake, and converts it into a Delta table. So this is what enables it to write Delta, both locally, and when we run this in Fabric, it's going to write to our Lakehouse tables area via the ABFS path. So the paths are all managed in this metadata.db. So this is a really important element of the DuckDB and DuckLake specifically solution. It's essentially like a metadata-driven framework table where you're just storing all of the paths to all of the files and the Delta tables and the Parquet files, where they all live in terms of the sources and the destinations. Now, we don't have to manage this. This gets automatically generated as part of DuckLake, but you can see all of the tables that we've got in our solution, and this gets generated for us. The path is very important, this one here, and the other important part is the metadata part, because this data path parameter is what we're going to tap into when we start to deploy these solutions to different environments, because this is a local data path. It's pointing to data tables, right? Which is here. But when we deploy into Fabric, this is actually going to change to an ABFS path. So then we're running the same DBT transformation code and config, but the data path is being passed in as a parameter, and it works with the ABFS path, which means we can deploy the same configuration into a dev environment, a test environment, and a production environment. And we're only changing this one parameter that we can change as part of the metadata.db. So that is a very core finding in this whole thing. The other defining feature of this solution is also, if we look in the profiles, still in the MIM example for now, I'll move into my own changes a little bit later on. The profiles here, MIM has included 3 profiles. There's the dev profile, the dev output profile here, and the CI profile here. So he does running continuous integration in a GitHub action using a tool called Azurite. Now that's not something that I've brought through into my own solution. And this one is the one for Fabric. So this is what I was mentioning here. Metadata local path is an environment variable that gets passed in when we run it in Fabric. Okay, so that's this path, data path that I mentioned. In the metadata, this is how he's managing the substitution for paths in different environments, essentially. And it's all in memory, no matter what the deployment environment or the profile, they're all in-memory based solutions, which does bring up a constraint, right? Your data needs to be small enough so that it can run on these machines, right? On your local machine. Now, for my project, that's not a constraint that I'm worried about, because when you're dealing in the millions of rows, you're going to be fine with DuckDB. Once you get into the terabytes and petabytes, that's when DuckDB probably isn't a good solution for you. But I want to explore that upper limit of scaling. I'm going to be keeping an eye on that, at least, as we move through the project. So that was MIM's example. As I mentioned, the next step for me was to essentially take the learnings and try and build that out for myself. So this looks like a final project, but actually I started this one as a blank canvas and built it up with the help of Claude to try and, in my own mind, solidify the concepts, understand things like the profiles, the DBT project, how the macros work. And macros in DBT are kind of like functions, but they're written in SQL. So understand how the macros work and how they get implemented in the different models in that solution. So then what I did is created this POC local dev based on the learnings from the previous 2 DBT projects, MIM's one and my own one that I created. I looked at my own requirements for my projects and thought, okay, how can I take these elements, these ideas, these technologies, but get them to work in the way that I want for my project? As you can see, the POC local dev is a bit messy because, as I say, this was research. And I started to play around a lot with the technology and do different deployment scripts and setting up different environments. I'm not going to show you all of that. It's probably better to actually show you the final result. So because that one was so messy, I then created POC local final clean. And this is a bit closer to my final solution. So the DBT project file for my particular use case looks a bit like this. It's quite simple. There's just a little bit of like materialization in terms of tables and views that gets defined in the DBT project, just so that it doesn't have to be done in each individual model file. I haven't changed anything here, so we're still calling onRunEnd, especially the delta export, and that is what is producing the tables in my case here. So we've got DBO. I got Claude to generate an ontology based on some film data. That's why it's all like director and cast, and I used that as the basis of my particular research here. But it's exactly the same as what there is in MIM's example. These are delta tables. This is effectively my gold layer that I'm going to be binding to my ontology. All right, so now that you've got a bit of an understanding about how DuckDB works, how it's integrated into DBT, and MIM's example, and some of the POC work that I did, I think it's best to switch back over to Excalidraw because I can try and explain the development workflow that I'm planning to execute on this project. So everything's going to start in the local development environment in VS Code in my DBT project. Essentially what I'm going to do is work with Claude, most likely, to make updates to my DBT models here, or testing, depending on what needs to change in the ontology, for example. All of this is going to be done on my local machine. Okay, so I'm going to be using DuckDB as the engine. It's going to execute on my machine. We're going to develop new SQL models. I'm going to call DBT run, DBT test, all of that good stuff. And it's going to populate the data tables area on my local machine in my VS Code project. Once I'm happy with the models and they've passed locally, the next step that I'm going to implement in my deployment process is to deploy it into a Fabric workspace that is not production. I'm calling it dev, but you could call it test maybe. And all that gets deployed in this scenario are these files here. Essentially your DBT config. It's your profiles, your schemas, your DBT project file, your models, your metadata.db SQLite database. This gets written into your dev lakehouse files area, like so. Okay. Now, when you first write it, your gold tables, for example, might be empty. But when we run our notebook, which is going to execute this DBT configuration, then the gold layer tables are going to populate in our dev lakehouse. Now, I want to do it in Fabric because I want to check that the DBT configuration, it works inside Fabric with delta tables, with lakehouse tables, all of that good stuff. But I don't want to do this for the first time in production. So this is like the second environment in which I'm going to test this DBT configuration against. Now, you might be wondering, how do you call it? Well, I'm going to be using the Python notebook library here. Let me just open. So this is what my dev lakehouse looks like. Now, I've already run it, so it's got like raw tables here, and it's got some kind of like gold layer tables in here. But in the files area, crucially, we've got the metadata.db. And this is essentially just writing these files into one lake. It uses Fabric CLI under the hood, but you can use a variety of methods. It's just writing files into one lake, really, is the deployment mechanism here, plus all of our DBT configuration files. Some of these are not required, but just because this is a bit of a messy project, essentially all we need is the models, macros, the DBT project. This is important, obviously, and the profiles. This one. So these are the core files that we need to deploy. And then our notebook looks a little bit like this. And again, I haven't really refactored much from MIM's example, but this is a Python notebook. So again, super quick to install or set up and very cost efficient in terms of CU usage. We do need to install DuckDB and we do need to install DBT DuckDB as well. These two packages, and then we need to restart the interpreter with those new packages. And all this does really is it uses the DBT runner, which is included in those packages that we install. We do a little bit of understanding where the notebook is running because this same notebook is used in this environment, like the test environment, and also in production. So we need to get the lakehouse and the workspace ID, and we construct the ABFS path. And then this is passed in via this operating system variable, essentially, metadata local path. And then all we do is do DBT run, like so, DBT test, and we handle the result here so that if this fails, the notebook itself fails. This is useful because I've actually developed GitHub Actions to manage this deployment process and the triggering of this notebook. So it's helpful to know if any of the DBT run, the model build and testing phase fail, so that we can fail the GitHub action. I haven't really showed you that bit, but that's another part of the deployment process that I developed here is deploy to dev. Now this is quite basic. We just authenticate with Fabric, install mostly the Fabric CLI. We deploy all of our artifacts. So this is the copying of those files. And then we do run DBT in dev, which just uses the Fabric CLI again to run our notebook. This is why it's quite useful, have that error handling and throwing an exception if the DBT tests fail, because I know this gets triggered automatically. If this fails, then there's something wrong with the DBT configuration and we can go back to local, but we're not doing it in production. This is still in the dev, the test environment. Whilst we're here, might as well have a look at the deploy to production GitHub action as well, which is very similar. Now, I haven't properly formulated this, but it's a very similar workflow in that we are using the same deployment script, but we've got a parameter here, target prod. All that does differently is it deploys to the production lakehouse, okay? So if deploy to dev works perfectly well and all of the tests pass, it's not a completely automated CI/CD pipeline, although you could do it like that, because I want to have a look at the data, make sure the bindings are working with my ontology, and then analyze the graph a little bit before I deploy to production. So at the moment, this is going to be a manual step, at least my current thinking, but the deployment is pretty much the same. So just to go back to the process, we're happy with it on my local machine. It gets deployed into Fabric, into the, you could call it pre-prod or test or whatever you want, really. Some area that's not your production environment. Rerun it again in these Fabric Lakehouse environments, the dev one, and then make sure that the tables populate correctly as you expect. Make sure that all your tests, your data quality tests, pass. If you're happy with that, then again, we can do the deploy to production, which does exactly the same thing, but just with a different target lakehouse, right? So it's writing to the ABFS path of the files area in our prod lakehouse this time, and then it's going to rerun it in production. Now, we've already checked that it does work in dev, so it shouldn't be any issues. I'm probably going to add some rollback functionality in there. So if there are issues, then we just roll back to the previous version. Haven't implemented that in the feasibility stage, but this is essentially how it would work. Now, that's my deployment process. Hey, Claude, I'd like us to test the DuckDB and DBT development workflow that I've been researching over the last few weeks. And specifically, I want you to make some changes to the ontology that we've got in Fabric, the film production ontology specifically, that we've developed just to showcase and do some research and feasibility studies into these workflows. And the entity and table that I want you to update is the film table. Specifically, I want you to add a new release decade column into that gold layer film table. It's going to be based on release year. So for example, a release year of 2019 will get converted into the release decade of the 2010s. It's because I want to perform some analysis of films over different decades. So I'm just going to send Claude off this prompt, and you can see that I've actually developed a new skill over the last week or so, which encapsulates some of the research and the workflow that I've been developing towards. Now, this skill, and we'll track it as it kind of continues going through. I might just need to give it some permissions as we go through. But the process of the skill is it's going to create a feature branch, which I can see it's already done down here. It's going to update my ontology. So if you were watching in the last video, I spent quite a lot of time understanding how the ontology works, how the graph works, specifically how we can automate updates of it using natural language, which is what I've just done here with this voice prompt here. So in step 3, it's then going to write some GQL validation queries that essentially are going to take my business level questions and features and write GQL kind of like unit tests to check that I can run at the end of this process, so that we can check if these columns and the entities and the properties of the entities have been properly implemented. I've then created this sync tool, is what I would call it. Now, this has evolved a little bit from last week when I created the Lakehouse sync functionality using the Livy endpoint. I've actually moved away slightly from that because now, having researched DBT a little bit more and the DuckDB method, everything can be handled by DuckDB and DBT, so there's no need to do the Lakehouse syncing, although it's pretty cool. Instead, what we do is this sync tool essentially looks at the item definition of the ontology in dev after you've made the changes to it, and it looks at our DBT models and it compares the two. And so it basically looks at what the gap analysis is, and it's going to output what's called a DBT changes.yml file into our folder here that we're going to keep track of what we need to change at each stage. Now, this is important because then in our next step, we then ask Claude to implement the DBT model changes. So it's analyzed what needs to change based on the updated ontology. Then we're going to get it to try to implement a fix directly on the DBT models. This is quite a small change, so it should be absolutely fine. And then we're obviously going to get it to validate. So one of the key benefits in using DBT for this process, and specifically locally DBT with DuckDB, is that we can get it to write the code and then run all of our data tests and unit tests. And we'll look at how that works with DuckDB as well for the data tests. This adds a little bit of a layer of control because, yes, we are hoping to get Claude support with the development of changes to the DBT models, but we've got about 50, I think, data tests in there. So they're going to run after we make these changes to make sure that we're not introducing or regressing the quality of our code. And then after there, we're going to commit the changes, and then I'll show you the deployment pattern for like test and prod afterwards. But let's just check on where we've got to. So after our initial prompt, essentially it took a look through the Claude Skill to understand what the workflow looks like and just to refresh its memory on what it needs to do. It created the feature branch here. So adding a release decade, it's created the feature branch, it's updated the ontology. So it's created a requirements and change folder. So I've essentially got it to document all of the changes that it's making to the model. We're still in dev here at the moment, but it's still good to document exactly what we're changing so that, if I'm coming in to review the code, I've got everything in this folder ready to go. That's this folder here, by the way. So I don't think it's finished writing everything in there, but we've got the prompt, which is the initial prompt that I gave it, like through the voice at the beginning of the video. We've then got this definition before.json. So it takes a snapshot of what the item definition is before we make any changes to it. This might be useful for if we make any mistakes and we want to roll back to a secure, stable version of the item definition. We've always got that there. So current film entity has these properties. Proposed change is to add a new property of type string to the film entity. Since release decade is a computed field derived from it, we have a design decision. Add to ontology and data binding. This column would need to exist in the Lakehouse table. So this should be option 1 because we want it to update the ontology and then bind the data to it. Now it's going to generate and run the update script. This is based on code that we used in the previous week's example, which was all of the ontology code. So we created some different clients, and specifically this one's going to be the definition builder, which can have a look at an item definition for an ontology and just change little bits of it quite surgically, which is quite nice. So it's created a Python script, and I can have a look at what that Python script is. So it's going to be in DuckDB, the POC local final clean, ontology changes, it's this one here. So this one is the Python script that updates the ontology that is generated based on the library. So it's using a lot of the tooling that we created before. So I'm going to accept this. All right, so now it has successfully updated the ontology, and it's just going to run a validation script, essentially, to check that those changes have been applied successfully to the ontology. Now, this is the dev ontology that we're currently working in. Okay, so now it's going to start with step 3. So it's going to write GQL validation queries. Okay, so what it's done is essentially written some GQL scripts based on the competency questions and the user prompt right at the top. It's understood my intent and what I want to do with these tables, and it understands the data to a certain extent. Which films were released in the 2020s decade is it the competency question that is assigned, and then it's essentially written the GQL to answer these competency questions. The other one is how many films were produced per decade. So it's basically writing these as kind of like unit tests on the graph, so that whenever I make future changes to the graph, we're going to rerun all of the GQL tests as well to make sure that there's still integrity. We can still answer all of our analysis questions that we want over the graph in the future when things change. So that looks good as well. We'll also use it in the development process, right? So at the end, when we've passed all of the DBT tests and we've run DBT, I'm going to run the GQL queries to check that the bindings are working, to check that everything's working in its place. So let's just tell it to continue. So I think it's just used a different virtual environment there. All right. So the sync tool has detected the new release decade column that needs to be added to the particular DBT model that we have in our project. So it's analyzed the ontology and it understands what we're trying to do. And now it's having a look at the DBT project to look at which of the models need to change and in what way. And then it's going to go and implement those changes to the DBT models. So it's adding a particular release decade. Now, this is a pretty trivial change. It also adds schema changes as well to the schema.yml. And then it's going to run through DBT run and DBT test locally. All right, so the workflow has now successfully completed this Claude Skill that I've developed. And this is what it's done. So the first step was to create a feature branch to make sure that we're not changing anything to the production ontology and tables and DBT models. We then created some updates to the ontology based on the input prompt. Everything got changed or stored in this folder here. And we can store these and check these into version control just so that we can see what changed at every feature branch, for example. And in here, we've got the original prompt, we've got the item definition for before any changes were made in case we need to roll back. We've got the Python script that updated the ontology. And we've also got a summary of the DBT changes as a YAML file. This gets fed in to Claude as part of the skill to help it identify what needs to change in the data model. It also wrote some GQL queries, and we can now run these in Fabric or locally as part of our deployment process, perhaps, to make sure that the tables that we generate now with DBT are properly bound to the ontology and they produce the right results based on how the structure is created. We then did this syncing tool, which effectively analyzed the item definition of the ontology and analyzed what we have in our repository for DBT models and then compared the two. That is where this DBT changes came from. That got fed into the implementation of the changes. So we updated the DBT models to reflect the changes. And then we ran through 54 tests and all of the models built successfully. So that's a good starting point for our development process. All right, and so just to round us off, I'm just going to bring us back full circle. And so hopefully you can see now how these technologies, DuckDB, DBT, and DeltaLake are, I think, definitely going to help me optimize this layer of my architecture, building transformations and SQL models from raw into gold. Now, these techniques are slightly outside probably like the conventional method that you would be used to if you've been working in Fabric for a while, using notebooks and that sort of thing, and pipelines and all of that. But I'm pretty happy with the results of this feasibility test. I will say that DuckDB and a lot of the approaches that I show in this video, as I've been mentioning all throughout this series, are experimental. These are not officially supported by Microsoft, these methods, so bear that in mind. If something breaks or goes wrong, you're kind of on your own. What I'm going to do is I can put my version of this POC local final clean in a GitHub repository, so you can have a look at this approach. I'll leave a link to that in the description below. But hopefully you found that useful and interesting to try and understand my current thinking about how to work with DuckDB and DBT. Thanks again to Mim for providing the inspiration for this workflow. And I look forward to continuing this project. In the next video, I'm going to be working a little bit more on the consumption layer of my architecture. So understanding what's going to come after our ontology. I'm pretty happy with data agents, and I know how I'm going to configure those and test those and deploy those. But there is a bit of a risk, at least like an unknown risk around web apps. So that's going to be the focus on what I'm going to be doing my research in the next video. I hope to see you there. If you found that useful, please leave a like and share a comment about what you're seeing in this series. If you're finding it helpful, definitely let me know. It helps me keep motivated to keep sharing these videos on YouTube. And if you have any questions, obviously leave them in the comments below. And I look forward to continuing this project in the next video. I'll see you there.